for the nitrogen. Coefficient for the nitrogen is 1. 1 mole of nitrogen combines with how many moles of hydrogen? 3 moles of hydrogen to form 2 moles of NH3. Okay, NH3 is nitrogen trihydride. Since it is industrially important, we are using its industrial name, which is called what? Ammonia. So whenever you see NH3, I will always say ammonia, ammonia. Its IUPAC name is nitrogen trihydride. Okay, so according to the mole ratio, we can see there is 1 mole of nitrogen combined with 3 moles of hydrogen producing 2 moles of ammonia. So we are using a ratio between the moles, which is called mole ratio. Okay, so according to this reaction, how many moles of nitrogen there? 1, just go and write 1 there, combines with the 3 moles of hydrogen producing 2 moles of ammonia. Okay, so there will be question calculating the moles of one reactant to another reactant or another product. Then we are using mole ratio for that conversion. All conversion needed mole ratio. Then remember about the particles. What are the different particles? What are the terminology we are using for particles? The formula unit, yes, like formula unit, molecules, atoms, and if there is single ions, we will call it what? Ions. So formula unit, molecules, atoms, ions. Formula unit for ionic compounds, molecules for equivalent compounds, atoms for single atoms, and ions for single ions. Okay, so I'm going here. If it says 1 molecule of nitrogen reacts with the 3 molecule of hydrogen, produce 2 molecule of ammonia. If we are considering like 1 molecule, we can say 1 molecule of nitrogen, 3 molecule of hydrogen will produce 2 molecule of ammonia. But we will not use that as molecule. We will always refer those number into mole. Okay, so the conversion factor we are using to convert mole to particle is 1 mole is equal to how many? Anyone remember that? 6.02 times 10 to the power of 23 particle. So if you have 1 mole of nitrogen, we can say that is 1 times 6.02 the power of 10 to the power of 23 molecules of what? Nitrogen. You have a question?
I need to take the progress check for like the unit 4.
1 second. Okay. So do these two, one is a PC and one is a practice, okay? Okay, so here there are 3 moles of hydrogen, so you can write 3 moles of hydrogen will be what? 3 times Avogadro number, okay? Which is 6.02 times 10 to the power of 23. This 3 comes from this equation, okay? And if it is 2 mole of ammonia, we can say that is how many molecules of ammonia, which is 2 times 6.02 times 10 to the power of 23 molecules of ammonia. This is molecules of hydrogen. Okay, so there will be conversion asking from particles to particle or particles to gram or particles to mole. Okay, we are using this conversion factor. Then another conversion you are going to see, we already saw that it is calculating mass. Okay, mass, remember 1 mole of anything, I'm going to say 1 mole of X is equal to what? The molar mass from periodic table. Okay, so molar mass from periodic table. And we can prove that will obey the law of conservation of mass in a minute. Okay, let's go see. Nitrogen, what is the mass of nitrogen in the periodic table? 1 nitrogen is what? 14.01. So 1 nitrogen is 14.01. You have to multiply with the subscript, which is 1401 times 2, 28.02 gram. Okay, that is just 1 mole. Okay, then we can write that is a mass of 1 mole of nitrogen. You multiply with the 2 because the subscript is 2. And same hydrogen, 1 hydrogen is 1.01. Multiply that with the 2, which will be 2.02 gram. Since there is 3 mole here, there is 3 mole here. 1 mole is this much mass. I'm going to multiply with the 3. So you will get what? 6.06 gram. Okay, ammonia again, nitrogen is 14.01. There is only 1 nitrogen plus, there are 3 hydrogen, which is 1.01 times 3. So you will get 1 mole has a mass of 17.04 gram. Okay, because it is 14 and 3.03, and there is 2 mole here, so you have to double it, 2 mole, so that will be 37.34 not 37, it will be 34.08 gram. Okay, so now we can prove the law of conservation of mass. We can prove the law of conservation of mass. The law of conservation of mass says mass of reactants must be equal to what? Mass of products. Okay, now you can prove it. See, reactant is 28.02 plus 6.06. You will get what? 34.08. That's why we are using these numbers in the balanced chemical equation. Okay, only in a balanced chemical equation, the law of conservation of mass will be true. The mass of reactant will be equal to what? Mass of product. Okay. Okay, so now let's go write some mole ratio. This side. Okay, so here we already said if there is nothing, that means it is 1 and it is 3 and it is 2. So those are the mole numbers. If you want to write the ratio between nitrogen and hydrogen, look, 1 mole of nitrogen needed how many moles of hydrogen? 3 mole. Or you can write the opposite based on the question. Sometimes we need to flip the ratio. So if it is 3 moles of hydrogen, that needed what? 1 mole of nitrogen. Okay, go down, write the ratio between N2 and NH3. How many moles of N2? 1. And how many moles of NH3? 2. Flip it. Then if it is 2 mole of NH3, that is 1 mole of N2. Okay, now write the ratio between hydrogen and NH3. Hydrogen is 3 mole, nitrogen is 2 mole. Then flip it. It is 2 over 3. Okay, now let's practice that. There is an example given. Always you have to check whether the equation is balanced before you writing the mole ratio. This is balanced. Go ahead and write the mole ratio between aluminum and bromine. So it is what? 2 mole of aluminum will react with 3 mole of what? Bromine. Right? Okay, we can flip that. If 3 mole of bromine on the top, then you can write 2 mole of aluminum on the bottom. And if you write the ratio between aluminum to aluminum bromide, okay, that will be 2 mole of aluminum on the top and 2 mole of aluminum bromide on the bottom, and flip it. You will get another ratio. You can write a ratio based on the question. You don't need all this ratio for the question calculation, okay? Just one is needed. Okay, if you are writing a ratio between these two, it will be what? You understand how to do that? If you are writing between these two, it will be 3 mole of bromine and then 2 mole of what? AlBr3. Then you can flip that, okay?
Yeah.
Then you will get one more ratio. Okay, so now let's go practice that. Let's do one calculation. I'll do 2 questions, then rest of that you can do it because it is the same. Let's do it. Okay, here, read the question first. The question says, how many moles of nitrogen hydride? Nitrogen trihydride is ammonia, and the given is 6 moles of nitrogen. Okay, go ahead and write that. The given is 6.0 moles of nitrogen. And you are going to convert into moles of NH3. Okay, that means you need a ratio between these two. And remember, I'm going to write the equation one more time. N2 plus 3H2 giving 2NH3. So we need a ratio between what and what? We need a ratio between this is your given and this is your unknown. Write the ratio between these two, and remember, whenever you write the ratio, the given mole must be on the bottom like this. Okay, let me write that. So the given is nitrogen, so I will write 1 mole of nitrogen and it will produce how many moles of ammonia? 2 moles of ammonia. That is the ratio you are going to use. So remember, like add a note there. Mole ratio, okay? Mole ratio. The given reactant or product, whatever, the given moles will be on the bottom, mole ratio, okay? And unknown compounds mole will be on the top because we are going to write that. So we'll start a T. This is our T chart. If you want to draw like this, that's one. If you don't want, that's also fine. So write the given here and use the mole ratio, okay? This is the place we are writing the mole ratio, okay? So when you write the mole ratio, look at the given. Nitrogen is the given. So 1 mole of nitrogen and unknown is 2 mole of ammonia. Okay, now like all normal calculation, you are crossing moles of nitrogen with moles of nitrogen, multiply the numbers on the top, divide the numbers on the bottom. If you want to like write a 1 here to show that as a ratio, you can, otherwise it's okay. So 6 times 2 is 12 and you have to follow the sig fig rule. This one has 2 sig fig, so I will write the answer with the 2 sig fig. Got it? Okay, let's do one more. Then after that, you can practice. Okay, this time we are going to directly do that. Okay. Okay. So check whether the equation is balanced. That is the first step. This is balanced. Okay. And the given is this. So we'll start the T chart from the given, which is 0.04 moles of potassium. Okay. And we need copy the unit down. That's how we are also moles of potassium on the bottom, and you are going to find moles of hydrogen which will be on the top. So you need to fill the numbers from the equation. How many moles of potassium in the equation?
2.
2. And how many moles of hydrogen in the equation? Look.
2, 4.
No, look at the mole number. This number, what is it? 1 mole. Always only look at the coefficient for deciding the moles, okay? So now we are done, okay? Just calculate. The moles of K and moles of K will cancel out, and you will get the answer is what? 0.02 mole of hydrogen. Okay, try this one now. Given is what? 6.8 mole of potassium hydroxide. And copy that unit down. That will help you to decide which one will go on the bottom. Moles of KOH on the bottom. And what is the unknown? You are looking for what? Moles of water. So water will be H2O. Okay, now look at the equation. Look at the coefficient in front of KOH on the left hand side. How many? 2. And water is also what? 2. So the calculation will be easy now. So you can, the moles of KOH and moles of KH will cross out. And you can also close this 2 and 2. So the answer is what? 6.8 moles of water. You understand? Okay, then these questions you are going to finish it. And remember, always need to check the equation is balanced or not. These two are balanced. This is not, because you are not seeing any numbers, or you have to check it. This is balanced and this is not balanced. So always make sure you balance the equation before you start the calculation. Okay, that's it.